Alright, in this video we'll be solving rational equations. This is actually the second of two videos. We've already talked about how to find a least common multiple, or LCD, how to rewrite fractions so that they have the same denominator. So now we're going to go ahead and solve some rational equations, and so we're going to use these 5 steps. On number 1 here it says list any restrictions. So for example, in number 9, we know that x can't be 0. Any value of x that causes the denominator to be 0 has to be, well, it's a restricted value. So x cannot be 0. We'd be undefined if we got a 0 for x when we solve here, and we plug it in, you can see we're undefined. So first of all, we want to find our LCD now that we've done that. Then we're going to clear fractions by multiplying each side by the LCD. We'll have an equation to solve at that point. And if we get any solutions that are a restricted value, we have to throw those out. All right, so let's go ahead and start. So here our LCD is the least common denominator, or least common multiple of x, 8, and 4. Well, to find the least common multiple of 8 and 4, I just usually have students start with the bigger number in the denominator, and notice that number is divisible by 4, and so we're done. If that didn't work, we would have continued on. And so it is 8. And so and actually we also have an algebraic factor in the denominator, so we have to include that x as well. So 8x is our LCD, so we're going to multiply each side of the equation by 8x. Now, I could put parentheses here, and we're going to end up distributing here. So I'm going to go ahead and just multiply each of the terms by 8x. So in other words, when I multiply both sides of this equation by 8x, I have to distribute that on the right side. So each term gets multiplied by the LCD. Well, 8x, here the x is going to cancel with this x, and you have 8 times 1. So 8 equals... Notice here our 8's cancel, and you have x times 1, or x. And here 8 over 4, that's going to be 2, times x times 3, that's 6x. So minus 6x. Well, a 1x minus a 6x is negative 5x. So we have negative 5x equals 8. We'll divide each side by negative 5 to get x by itself. And so we're going to get x equals negative 8/5. And notice that's not our restricted value, which was 0, and so that's a perfectly good solution. All right, on number 10 here, notice again x cannot be 0. 2 times 0 would be 0. If my denominator is 0, I'm undefined. For my LCD, to find the LCD for 2x, 9, 18, and 3, well, for the numbers, notice 18 is divisible by all the other numbers. That's my biggest factor, or biggest number in the denominators. So my 18 is going to be part of my LCD. And notice we have an x factor here and here. And we take the highest power that we find, and they're both to the first power. So 18x is our LCD. And so every fraction, or every term, will get multiplied by 18x. So here the x's cancel. 18 divide 2, that's going to be 9. You're left with 9 times 5, or 45. Here 18 divided by 9 is 2. You're left with 2 times x times 8. So what's that, 16x? And on this side, the 18's cancel. You're left with 1 times x, or x. Here, the x's cancel. 18 divided by 3 is 6. So minus 1 times 6 is minus 6. So notice we have a much nicer equation now. We've been using CSI to solve equations like this. These are linear equations. We've cleared fractions by multiplying each side by the LCD. We don't have any simplifying to do, because if you look at each side, there's no like terms, nothing we can simplify. We do need to isolate x on one side only, so we need to take care of that. Let's subtract x on each side. And so we'll just have x on the left. And so we get this two-step equation. Notice we're going to have to subtract 45 to get rid of the 45, and then divide by negative 17, all as we try to get x by itself. We always add or subtract first, so let's do that. We get negative 17x is equal to negative 51, and you can divide by negative 17, and you'll get x is 3. Turns out 3 times 17 is 51. Now remember, we said x can't be 0, and so we're okay here. Our solution is just x equals 3. All right, let me adjust my camera here. By the way, I have to warn you, I have some dogs outside that I don't normally have, so they may be part of this video. You may hear them, we'll see. So here you can see again, x can't be 0. That would cause this denominator to be 0, we'd be undefined. So we can never have a solution of 0 for this equation. And then our LCD is 0. I'm sorry, not 0, but x. So we're going to multiply everything by x. And x times x is x squared. 22, well, let's see, the x's cancel here. You get plus 22 equals negative 13x. Now notice this is not like the two equations we just solved above. This is a this is a quadratic equation. So we want to get it in the standard form, the x squared term, then the x term, then the constant with 0 on one side. So let's add 13x to both sides. We get x squared plus 13x plus 22 is equal to 0. So when we factor this, we can use the AC method. And I'm assuming at this point that you can do that. I won't spend as much time on this step. We know x times x is x squared. Because this is a 1, we don't have to split our middle term and factor by grouping. We can take the two numbers we get and just plug them in. We need two numbers that multiply to 22, that's our AC, and add up to 13. Well, 2 times 11 is 22, and notice those are the numbers that work. There aren't many to look or to check out. So we have plus 2 and plus 11. And so when we set each of those equal to 0, we're going to get negative 11 and negative 2. Now remember, we said that x can't be 0, and so neither of those are 0, and so those are perfectly good answers. All right, let's move on to number 12. Now the first thing I hope you'll see here is that x squared minus 4 can be factored. This is a difference of squares. It'll be x minus 2 times x plus 2. And so notice when you're looking for your LCD, it's going to include each of those factors, x minus 2 and x plus 2. Those are the only factors that we find in the denominator. And they're all to the first power, so we don't have any higher power. You don't need to multiply these together or these together. We just take each factor found to the highest power found. And so if I multiply each term by this LCD, the fractions should go away. So let's go ahead and do that. X minus 2 times x plus 2. And we'll do that here and here. By the way, I forgot to put my restricted value, or in this case there's 2, right? Notice here 2 minus 2 would cause my denominator to be 0, so x can't be 2. Notice here it couldn't be negative 2. And we have the same factors here, so that doesn't add anything else to our restrictions. So here when I multiply this times this fraction, my x minus 2's are going to cancel, and I'm left with 3 times x plus 2, the quantity x plus 2, minus, and then here notice both of these cancel with both of these, so it'll just be minus 2x. On the other side, the x plus 2's are going to cancel here, and I'm left with 5 times x minus 2. And so let's go ahead and distribute. We're going to have 3x plus 6 minus 2x equals 5x minus 10. We're just distributing here. So we're in the process of simplifying. We already cleared fractions. Now we're simplifying. So we've got some more work to do. We can combine these two terms. We're going to have 3x and minus 2x. That's a 1x plus 6 is equal to 5x minus 10. So everything's simplified on each side. I want to get x on one side only. I think I'm going to go ahead and subtract x on both sides just to keep things positive. You could have subtracted 5x on both sides and that would work too. So what is that? 4x minus 10. And let's see, we need to get x by itself, so let's add 10 to both sides. 16 is equal to 4x, which means x equals 4. Notice that's not one of our restricted values, and so that is our solution. All right, let's move on to the last page. So on number 13, we have a numerical value in the denominator of 5. And we have an algebraic factor of y plus 2. All I can do is multiply these together, and that gives me my LCD. Notice also y can't be negative 2 here. And so we're ready to clear fractions. Let's multiply each side by 5 times y plus 2. So on the left here, notice these y plus 2's cancel, and you're left with 5 times y minus 2. On the right, these 5's cancel, and you're left with 3 times y plus 2. And so now we just need to solve this equation. We'll have 5y minus 10 on the left. I'm just distributing. Same thing on the right. We get 3y plus 6. I've got everything simplified now. I want to get rid of the y on one side. Let's go ahead and subtract 3y on both sides. We get 2y minus 10 is equal to 6. And I need to add 10. Now on each side, we get 2y is equal to 16, which means y is 8. Notice that's not a restricted value, so we're good there. That is our solution. Now I want to show you something. There's an easier way to solve this problem, and we'll use it on number 14, and we could have used it on 13. Let's say you have the fraction 2/3. Well, think about a fraction that would be equal to 2/3. You can pick whichever one you want. All right, I'm going to pick 20 over 30. You could have chosen 4/6, or what would it be, 6/9. So really you could just multiply 2 and 3 by the same number. I use 10, and get any equivalent fraction. These are equal. This is simplified, this is not. But no matter what you choose, I want you to notice, if you look at the cross products, 2 times 30 and 3 times 20, those are equal. So these are called cross products. Whoops, cross products. In a proportion where you have a fraction equal to a fraction, the cross products are always equal. Notice I made a mistake here. This should be 2 times 30. 2 times 30 is the same as 3 times 20. This is always true with proportions. Now, if you look at the problems that we solved on the previous page, none of those were a fraction equal to a fraction. That's what we refer to as a proportion. And so this can only be used when you have fraction equal fraction, or a proportion. So here we can say 7 times x minus 3 is equal to 5 times x plus 1. Now you could put the 5 after the x plus 1, but we normally put it in front. And it really doesn't matter which way you go first. I could have put my 5 times x plus 1 on this side, and this could be on that side. So now we're ready to distribute. We get 7x minus 21 is equal to 5x plus 5. We'll subtract 5x on both sides. Because everything's simplified, we just need to get x on one side only. We get 2x minus 21 is equal to 5. Let's add 21 to both sides. We get 2x is equal to 26, which means x is 13. Now I'm going to go ahead and circle that answer, or square it. Forgot a couple of things. My LCD here is x plus 1 times x minus 3. We could have actually multiplied both sides by that and we'd get the same thing. We cross-multiplied because we have a proportion here. But we do also want to mention that x can't be negative 1 and also 3. So if we had gotten one of those as solutions, we'd throw it out. All right, last problem. So if you haven't already tried doing this, I would encourage you to try to do this problem and then watch the video. It's similar to number 12 that we did not long ago. So let's see how you did here. So hopefully the first thing you notice is this factors, and it actually factors into these two factors here. This is quite common in these types of problems. You can see x times x is x squared, 1 times 3 is 3, and you'd have a 1x and a 3x if you do your inner and outer product, and that's 4x. And so our LCD is x plus 1 times x plus 3. So here you multiply by x plus 1 times x plus 3. We'll do that times each of these fractions. So the x plus 1's cancel here. You're left with x times x plus 3, the quantity x plus 3. Notice here the whole denominator cancels. You're left with 3x plus 5, just the numerator here. Over here, the x plus 3's cancel, and you're left with 2 times x plus 1. Notice that's the right side of my equation. So let me move my camera a little bit. So we're going to get x squared plus 3x plus 3x plus 5 is equal to 2x plus 2. Now you'll notice that we got some simplifying to do here. Let's see, we can combine the 3x's here. We get x squared plus 6x plus 5 is equal to 2x plus 2. But we need to get 0 over here, so let's subtract 2x and 2. So the 2x will come out of the 6x, and we'll have 5 minus 2. We're going to get x squared plus 4x, and that's a plus 3 equals 0. When you factor this, you get x plus 1 times x plus 3. I'm just going to go ahead and factor this. Again, I'm just using the AC method. You may spend a little bit longer to verify that. So when we set each of these equal to 0, because that's what we do with quadratic equations, we get negative 1 and negative 3. Now, I tend to do this. I forget about my restricted values. I should have done that up here. Notice x can't be negative 1, because that would make this denominator 0. X can't be negative 3 either, can it? And so we actually got the two values that we can't get as solutions. So we have to throw both of these out. That means our solution is the empty set, or we would say no solution. So no solution or the empty set, that's our solution. All right, that's it for this video. I hope that helps. If you have any questions, let me know.